Hi, I'm Dr. Frank Summers, and this is Hubble's Universe Unfiltered. In this episode, we're going to have you seeing spots, specifically red spots on Jupiter. But we're going to begin by looking at white spots here on our home planet, Earth. This big white spot is Hurricane Isabel from 2003. And this is as it was forming, or after it formed, out in the Atlantic Ocean. And it's a great big swirling mass of clouds with an eye at the center. And if you take a look at that eye in the center, it's really quite kind of impressive. This eye is 40 miles across. And if that's 40 miles across, well, you can see there's this great big wall of clouds here that must stretch for miles. So this is a giant, huge storm stretching up in the atmosphere. How large is the overall hurricane? Well, here's another picture from when it made landfall on the east coast of the United States. And you can see the bottom parts of the hurricane are down here around Florida, and they stretch all the way up the east coast, and the top parts are up here around Cape Cod. This is about 1,200 miles across. That's kind of impressive. And it swept across land, and we're up here in Baltimore, and it swept past us here in Baltimore. We lost power for a few days, and parts of downtown Baltimore were flooded. And this is a relatively large storm. How large can be shown from an image from the International Space Station. And here you can see the curvature of Earth, and you can see Hurricane Isabel stretching across that curvature of Earth. Hurricane Isabel was about 15% the diameter of our entire planet. That's a pretty large storm. But from an astronomer's perspective, I gotta say, it's not really that large a storm. There are much larger storms in the solar system. Matter of fact, this image from Voyager 2 shows us the largest storm anywhere in the solar system, Jupiter's Great Red Spot. And this has got to be one of my favorite images in all of astronomy. Not because of the red spot, but also because all of this turbulent flow along here. It's just the gorgeous dynamics that happen in Jupiter's atmosphere. Now, the Great Red Spot is a storm that we have seen for at least 200 years. We have continuous observations of the Great Red Spot since the early 1800s. And there are some indications that we may have actually seen it as early as 1670. If that's true, this is a storm that's been lasting for 350 years. And it's not just the red spot that's a storm. This white oval here, that's also a storm. And this one's a storm. And that one's a storm. And that's a storm. And that's a storm. And that's a storm. There are storms all over Jupiter, or the face of Jupiter. The Great Red Spot takes on special significance when you put it into context. And to put it in context, this is the correct relative size of our entire planet compared to the Great Red Spot. The Great Red Spot is a storm that has lasted for centuries and is as large as our entire planet. Talk about your bad weather centuries on Jupiter. Man, that's some serious storm. Now, if you take the Great Red Spot in a different context, it might be similar to Isabel. Because when you look at the full disk of Jupiter, you can see the Great Red Spot is about 10% the size of the diameter of the planet. And I said that Isabel was about 15% the size of the diameter of Earth. So in some context, the storms are roughly comparable in comparison to the size of their entire planet. But in terms of longevity, well, the Great Red Spot wins hands down. Now, Hubble takes images like this, but Hubble has been up for 18 years and has been able to monitor the Great Red Spot for all that time. We released this image showing you how the Great Red Spot has changed from 1992, this first image, all the way down through I think it was 1999 when this image was released. And it's sort of an artistic presentation of the images. Oh, actually it's a cheat, because the image of Jupiter in the background isn't a full image. It's actually got a huge chunk cut out of it. So the reason why we had this beautiful artistic foray of the Great Red Spot was just actually to cover up the fact that we didn't have a full image of Jupiter. If you want to study the red spot over the years, it's better to lay the images out like this. And this is 1992, and this is 1999. Now remember, in 1992, That was before the first servicing mission to Hubble, and so Hubble's flaw in the mirror had not yet been corrected. So this image looks kind of ratty. But if you look at the red spot from here to here to here to here to here to here, what you see is that it doesn't change that much. It's a remarkably stable storm. Sometimes it gets a little bit more elongated, sometimes it gets a little fatter, it changes its shape a little bit, but relatively constant. It's a very long-lived storm, and it's the only red spot on Jupiter. Well, it was the only red spot on Jupiter, because going back to this image, you see these three white ovals here? We've been tracking the spots on Jupiter for a very long time and very carefully, and these white ovals were seen to form in the 1930s. They're also relatively long-lived. They lasted for about 70 years. But in early 2000s, they merged together to form one spot. And in 2006, that spot became the second red spot on Jupiter. For the first time in history, we actually have seen the formation of another red spot on Jupiter. Great red spot. What do you call this? We called it red spot junior. And when you look at it, you might say, well, wait a minute. Are great red spot and red spot junior somehow going to interact? They're going to collide anything? Well, take a look at this animation. This is a series of 14 frames from the Cassini spacecraft. Now, some of you may be saying, well, wait a minute, Cassini is supposed to observe Saturn. Yes, it is, and it's there at Saturn, but while it was passing Jupiter, it got some frames of Jupiter, and they put those frames together into a movie to see the motion in the Jovian atmosphere. And you can see how the bands and zones are going in different directions, and how these swirling storms here approach, and at the end of the sequence, one of them also gets absorbed into the great red spot. So you can see there the zones are relatively straight across, relatively east-west in their flows, or west-east depending upon what you're looking at. So when I go back to the picture of the great red spot and red spot junior, you can see that red junior is down below, on a latitude below the great red spot, and so we didn't expect anything to happen. Well, a few months after this image was taken, red junior did actually pass underneath the great red spot, and there was no major interaction. So, red spot junior may also become a very long-lived storm in the Jovian atmosphere. And so now we had two red spots on Jupiter. But the story's not finished there, because early in 2008, we got this image where we had the great red spot, we have red spot junior, and we had a third red spot appear. I mean, for 200 years we had one red spot on Jupiter, and now within the last 5 years we've got three. Something's going on here. What's going to happen when these two interact? And over the summer, the two did interact. So we got a series of three pictures. This first one is pretty similar to what I just showed you. It was taken on May 15th, just a few days after that last image. And then on June 28th, we got this image, and baby red was coming in really close to the great red spot. And finally, on July 8th, baby red had passed through the great red spot, and you can see that it had dissipated. So, the great red spot is a violent storm, and it should be feared because apparently the red spots eat their young. What we've gone from is having one red spot to having three red spots, and this indicates some sort of change on Jupiter. What's going on? Why are there suddenly so many red spots? Well, to understand that, we're going to go from the visible light image to the infrared image of Jupiter. This is an infrared image from the Gemini telescope. And so these big white things here are actually what we just showed you in the previous images as the red spots, the great red spot and red spot junior. Matter of fact, this is I think this is the first passage of red junior underneath the great red spot. And the reason why they're white in infrared light is because the clouds are much, much higher in the atmosphere. The great red spot and red junior, these red spots, have their clouds lifted much, much higher into the Jovian atmosphere, where a chemical change happens in the clouds that turns them red. We're not exactly sure what the chemistry is that's going on there. We just know that it appears that when you lift the clouds high in the atmosphere, they turn red. So instead of that sort of hole in this big wall of clouds that we saw in the hurricanes, instead we've got this sort of mesa, this plateau of clouds that's all swirling. It's all several miles higher in the atmosphere than the surrounding clouds. It'd just be a great big huge wall of clouds if you were flying through the Jovian atmosphere and the great red spot was there in front of you. The other thing is that these are bright in the infrared, which means that heat is coming out in these places. So the reason we think that these red spots are forming, now this is just a hypothesis, it hasn't been proven yet, but the hypothesis is that the poles of Jupiter are cooling while the mid-latitudes of Jupiter are heating. And if you heat up the atmosphere in the mid-latitudes, that energy has to escape from the Jovian atmosphere. And so the formation of these red spots, this increased storm activity and getting up to a higher altitude, is a way of getting the energy out from within the Jovian atmosphere. Now you'll note that these are very long-lived storms, and hurricanes on Earth, like Hurricane Isabel, last for only a few weeks. The reason that hurricanes on Earth only last for a few weeks is because eventually they hit land, and when they hit land, they dissipate. Their source of energy, which is the heat in the oceans, goes away. Jupiter, instead, is an entirely gaseous atmosphere. There is no land for these storms to hit. So it's a perfect laboratory for watching storms that can last for a very long time. And that's one thing that Hubble does very well by being an orbiting satellite observatory, looking out at Jupiter over years and years. And I can guarantee you we will continue to study and monitor the development of these red spots for as long as Hubble is up there. That's it for today. We'll see you next time on Hubble's Universe Unfiltered. Hi, I'm Dr. Frank Summers, and this is Hubble's Universe, all of clouds here that must stretch for miles. So this is a giant, huge storm stretching up in the atmosphere. How large is the overall hurricane? Well, here's another picture from when it made landfall on the east coast of the United States. And you can see the bottom parts of the hurricane are down really after it formed out in the Atlantic Ocean. And it's a great big swirling mass of clouds with an eye at the center. And if you take a look at that eye in the center, it's really quite kind of impressive. This eye is 40 miles across. And if that's 40 miles across, well, you can see there's this great big wall unfiltered. In this episode, we're going to have you seeing spots, specifically red spots on Jupiter. But we're going to begin by looking at white spots here on our home planet, Earth. This big white spot is Hurricane Isabel from 2003. And this is as it was forming after here around Florida, and they stretch all the way up the east coast, and the top parts are up here around Cape Cod. This is about 1,200 miles across. That's kind of impressive. And it swept across land, and we're up here in Baltimore, and it swept past us here in Baltimore. We lost power